Probability exercise 13.3 problem number 5. A laboratory blood test is 99% effective in detecting a certain disease when it is in fact present. However, the test also yields a false result for 0.5% of the healthy person tested. That is, if a healthy person is tested, then with the probability of 0.005, the test will imply he has the disease. If 0.1% of the population actually has the disease, what is the probability that a person has the disease given that his test is positive? Now I have read the problem completely. So we will solve the problem this way. Let E1 be the event has disease. E2 is the event has no disease. So remember this. E1 is the event has disease. E2 has no disease. Now in the problem, the probability of a person having disease, look here, has disease. The probability of a person having disease is 0.1%. So where is that in the problem? Look here. It is here. 0.1%. A person has 0.1%. The probability of a person having disease is 0.1% only, and that will convert into a decimal. See, it's in a percentage form, that we will change into a decimal form. That comes to 0.001. This is the probability of a person having disease. So PE1 is the probability of a person having disease is 0.001. The percentage has been changed into a decimal form. See how it has been changed. 0.1%. 0.1 is 1 by 10. 1 by 10%. 1 by 10%. 1 by 10 into 1 by 100. So I have divided everything by 1 by 100. If you calculate this, 1 into 1, 1 by 1000. 1 by 1000 is equal to 0.001. This you remember. Now, PE2, that is, has no disease. A person, the probability of a person not having any disease at all, that is PE2. Now, how did we find PE2 is 0.999, 0.999. How did we get this? Look here. We have a formula here. Probability that a person has disease, probability that a person does not have disease, the sum of this is equal to 1. We know that. Yes, no. Has a disease, has no disease. The probability of these two things will always be 1. Now we want to find out PE2, that is probability of a person has no disease. Probability that a person has no disease, that is 1 minus PE1. So from 1 you subtract 0.001, you will get 0.999, this one. That's how we have found PE2. So PE2 is 0.999. Now let A be the event. The result is positive. What is A? The result is positive. What is E1? Has disease. What is E2? Has no disease. What is A? The result is positive. Now look here. Probability that a person has been tested positive given that he has no disease. Look here. What is E1? No disease. That's how we have to read. Probability that a person has been tested positive given that he has no disease. What is that 0.99. That has also been given in the problem. Look here, it is here. Here, this one. 99%. 99%, if you change it into decimal, it will be like this: 0.99. Probability of a person tested positive, given that he has a, even he has a disease, is 0.99. That is given in the book. So what is the meaning? Tested positive given that he has disease. Tested positive given that he has disease. Now, probability that a person has been tested positive given that he has no disease. He has no disease, even then he has been tested positive. He has no disease, even then he has been tested positive. What is that percentage? That is 0.005. How did we get this? Look here, we have a decimal here. Percentage form. Look in this problem, we have this one. Look, 0.5%. This 0.5% we have changed into a decimal, as we have done earlier. 0.1%, how did we change into decimal? In the same way, you have changed 0.5% in the form of a decimal, and its value is this. This is the value. So look here, tested positive given that he has no disease. He has been tested positive even though he has no disease. That is this is the probability. Probability that a person has been tested positive given that he has no disease. Probability that a person has been tested positive given that he has disease. So these are the things we have found, and now these things we have to use in the formula. What we have to find out? Look here, this is what we have to find out. Look here, what is the probability that a person has disease, see, given that he had result is positive. He had a test result, given that he has test is positive. What is the probability that a person what is the probability that a person has the disease given that his test is positive. His test is positive. What is the probability that a person has disease given that his test is positive? See, this is what we have to find out here. See, probability that a person has disease given that a person has disease given that he has been tested positive. Look at the problem. He has been tested positive and even refers to he has a disease. Probability that a person has disease, he even has disease, given that he has been tested positive. What is here? Test result is positive. This is what we have to find out. Probability that a person has disease, given that he has been tested positive. Now the formula as usual. Look here, PE1 we write as it is, and PAE1. See, in earlier problems we have used this formula, and the same thing we write in the denominator. I have told you several times. Plus, now instead of PE1 we write E2, because we have got E1 and E2 here, as in the case of the earlier results. PE2 and PAE2. Okay, PAE1 here PAE2. So try to write this formula. PE1 bar A, or probability that a person has disease given that he has been tested positive, is this. Now all these values we know. Put them here one by one. Substitute them. PE1, this one, and all these we have found. See, for example, PAE2, where is that? PAE2. PAE2, how much? This one. What is PAE1? Here. What is PE1? It is here. This one. What is PE2? It is here. All those values you put here and try to calculate them. Okay. And this we change into a fraction form. 1 by 1000, 99 by 1000, and this again 1 by 1000, 99 by 100. See, 0.99 is 99 by 100, because for 1 we write 1, for the decimal point we write 1, and for these two digits we write 00. So that way we have changed all the decimals into fractions. So if you multiply, what happens? 1 into 99, 99, and 1000 into 100, how much? 10,000. And again here 99 by 10,000 plus. What about this 999 multiplied by 5? See, I have 999 into 5. And 1000 into 1000, how much? 1 lakh. 1 followed by 50. 1000 into 1000. 1 followed by how many zeros? 50, 1 lakh. And again, a simple calculation. This you write as it is. And this one, this is 10,000, this is 1 lakh. So 1 lakh becomes the denominator. If you divide this by 10,000, you will get 10. So 99 into 10. And this will remain as it is, because this is 1 lakh and the denominator is also 1 lakh. 1 lakh divided by 1 lakh is 1. 1 ones are this one. Multiply that. So simple calculations. So 99 by 10,000 I have written as it is. 10,000 or 1 lakh. 1 lakh written as it is. The 1 followed by 5 zeros. 1 lakh. And here is also 1 lakh. And if you divide that, what happens? Followed by 5 zeros. 5 zeros. Here we have got 6 zeros. Okay. So if we divide, what happens? It has more number of zeros. Here we have got 6 zeros here. We have got 5 zeros. So 110 remains here. So 99 into 10 you will get. Here, if you divide this by this one, you will get 10. Now 10 into 99, 990. And this we have written as it is. This denominator we have written as it is. So if you try to simplify this, finally you will know how to do that. Divide by 2. Divide this by, look here how much we have divided. So it's a simple calculation. So this fraction becomes this one, 22 by 133. This is the final answer. Okay. So you must follow this one. Okay. Thank you.